Hello everybody. Let's look at problem 2364. Count number of bad pairs. We are given a zero indexed array nums and a pair of indices I comma j is a bad pair if I is less than j and j minus I is not equal to num set j minus num set I. We are told to return the number of bad pairs present in nums. Okay, so let's look at the examples. Let's look at the example 4133. The number of possible from the possible pairs in this array of length 4 is 3 factorial, right, which is equal to 6. There are 6 possible pairs that are 4 1, 4 3, 4 3, 1 3, 1 3, and 3 3. This is index 0, index 1, index 0, index 2, index 0, index 3. This is index 1, index 2, index 1, index 3, index 2, index 3. And if we take a look at the combinations, the conditions that we have to solve this for. A pair is called bad if I is less than j and j minus I, right? So j minus I is not equal to num set j minus num set I, right? And out of these list of arrays, this satisfies that condition. This also satisfies that condition. This pair also satisfies. Uh, this pair also satisfies, and this pair also satisfies. So there are 1, 2, 3, 4, 5 different pairs that satisfy this condition. This does not satisfy because 3 minus 1 is equal to 3 minus 1, so it is a good pair. And for rest of the other cases, they do not satisfy that condition. So one thing that we can always do when we are solving problems that require some conditions to be met through equations, we can rearrange them, right? So let's see if we can rearrange this equation. So our equation says j minus I should not be equal to num set j minus num set I. The brute force way of solving this would be to generate all the pairs and then uh, try to see if they match that, but it is n square time complexity, right? We go of n square, but the length of the array is 10 to the power 5, so can be a possible solution, but we can improve the time complexity much further. So this equation, let's try to rearrange this. Let's keep all the j terms on one side and all the I terms on the other side, right? If we rearrange it, it will become num set I minus I is not equal to num set j minus j. So keeping all the terms on one side makes the equation much simpler. Now we have to just uh, try to find the places where num set I minus the index itself is not equal to num set j minus j itself. And to find these equations, we can again try to check where the condition holds and then try to negate it, right? And to keep track of the previous states, we can think of using a data structure like hash maps, right? And whenever the condition meets, we'll find the same difference for the um, value minus the index, and we can use that to calculate. I think this should be a fairly straightforward solution. Let's get started with the solution. So what we have is we'll have to create a hash map, right? Keep the track of the difference. So we can create a hash map to keep the track of the difference, and we have to loop through the array. So for each index and value in enumerate nums, enumerate is a function that gives the index and value as a uh, pair of iterables for each element. And what we have to do is we have to find the number of good pairs first. The number of good pairs will be so if while looping through the nums, if we have already found the difference, then it is a good pair, right? So we'll find the difference first, right? Difference will be b minus I. So if b is already present in the array, then we know the good pairs. Good pairs will be difference dot get b 0 initially, and we'll also need to keep a track of the bad pairs, right? So bad initially the bad pairs are 0. So if there are let's say good pairs, good pairs, then the number of bad pairs will be the position we are at, the index minus the number of good pairs. So the bad pairs will be the index we are at minus the count of good pairs. We found out the number of bad pairs, and after doing everything we have to keep add the difference that we got now to the diff hash map. So we have to just add the difference dot get b. If it is not 0 initially, then it has to be this plus 1, and we can replace this with good because we have already found this out, and then we can return bad. Test cases are accepted. Let's submit it. Submitted. Thank you.